Okay, we got a little spring break rust to work through. Okay. And just to put it on tape, mask mandate has been suspended. Hopefully it doesn't come back, because if it comes back, that means that this new variant is eating people up. Okay. Cases are down to the point where risk is pretty low. There were like 18 cases in this county out of 50,000 people last week, 18 cases, which means there are probably 200 people out there spreading it. Okay. Now that's 1 out of 250 people. Meaning there are 1,000 people on campus today, there are probably 4 people spreading it. So it's not low risk, it's moderate risk. Okay. It's low enough that I'm willing to take the risk, even though I can't afford any brain shrinkage. But it's going to happen with me anyway at my age. So, but I don't want to accelerate it. Okay, lose a few more brain cells, and I probably won't be able to find the room. So, my policy on masks is you're not required. I still encourage you to wear them, but not to the point where I'm going to hassle you. And if anybody's wearing one, I'll wear one. Okay. If nobody's wearing it, I won't wear one. But if it gets to the point where cases are starting to surge again, I'm going to wear one and just encourage people to wear one. Okay. Again, I won't hassle you. No, wear one. It's your choice. Unless there's a mandate. If there's a mandate, then we're going to be wearing it. And I appreciate y'all's cooperation. Y'all were really good about it. Okay. During the mandate. Okay. So we got something to factor. We've got x squared minus 8x plus 12. Well, that means that we have a number of possibilities. We could have x. Now, I'm going to write it this way. X, and it could be a plus or minus here. 12. X plus or minus 1. Okay. But the sign has to be the same. Otherwise, you wouldn't get 12. Okay, you'd have to have the same sign. And clearly, if you're going to get a negative here, that sign had better be minus. So we can smudge out the plus. And we can say, well, here's one possibility. Now that looks like an underline of life or something. So I'll put the minus up here. And then I'll write the rest of it a little more neatly. And we could have then x minus 6 times x minus 2. Or we could have x minus 4 times x minus 3. Or we could have, well, that's it. Okay. So if we multiply this out, that's x times x minus 1 times 12 times x minus 1, which is x squared minus x minus 12x plus 12. Well, no way that's going to work, because a minus x and a minus 12x gives you minus 13x. I could have written minus 13x here. And you would have gotten it in the first try if that was your first try. Okay. Now we come down to this last one. Right? X times x minus 3 minus 4 times x minus 3 distributive log, yeah. And that equals x squared minus 3x minus 4x plus 12. But that gives us 7x, right? Negative 7x, not negative 8x. So we better hope that this one works. Okay. And this one actually does work. You can write out the distributive law as well as I can. So whatever you have, you want to multiply it out. If you think you've got it, that's fine, check it. If you don't check it, a lot of people have wrong answers in some of these and didn't bother to check it, okay? Even though I said you need to check that. Maybe indicating you weren't sure how to check it, okay? Well, to check it, you use the distributive law. On the problem I gave you with symbols, people were pretty good with the distributive law, okay? So it's not like you don't know it, but make yourself do it. You won't know you got it right until you multiply it out, okay? And meaning you'll go on and keep making mistakes instead of identifying when you've made a mistake, go back and correct it, and pretty soon you stop making mistakes. So please do that. People who don't succeed in pre-calculus are almost universally people that never check anything. And very seldom does somebody pass pre-calculus that doesn't check things. Okay, you got to check your work. Okay. Now, some people just know it well enough that they can check it in their head. Okay, that's not real common, but yeah, there are people who can do that. Okay, this one. Now, there's two ways to factor this one. The easier way, and I'm not going to do it the easy way. Plus 36. Try to get all the numbers right. Like I say, I can't afford to lose any more brain cells. Okay. One way to do this, that's 3 times x squared plus 8x plus 12. So if there's a number that factors out, if the coefficient of x squared factors out, that makes it a lot easier. Okay. And I'm not going to. I'll just write out what that gives you. That's how it would be, okay? In general, though, this number is not going to factor out, okay? So if I write this down as now, if I don't know in advance that these both have to be plus, then I'd have to write out, you know, if there's a minus 36, for example, then I'd have to either put a plus here and a minus here, or a minus here and a plus here. Okay. And I'd have twice as many possibilities because there are 2 different possibilities for which one's minus and which one's plus, right? Or if this was a minus here, since both of these have to have the same sign, I'd have to have a minus and a minus, right? Yeah, just a second. Okay, what I was saying about brain cells, very relevant. Somebody asked me, should I have a 3x in both of them? If I were saying you thought there should be a 3x in both of them, because there's no way I would have written a 3x in both of them. Okay, I know better. I look back at the board and oh my gosh, remember what I said about brain cells? Okay, so yeah, if it was like this, you'd have a 9x squared, right? Now, if you factored it like this, you have a 3 times this, it shows you that 3 doesn't go here and here, right? If you were to put that back in. So that's kind of where I thought that might have been coming from. But that's not where it's coming from. It's just coming from the fact that I made a real bonehead error there. Okay. And when I got back to multiplying these out, I was only pretending to make an error so I could show that it didn't work. Well, you know better. Okay, so anyhow, it's got to be 2 pluses because that's what it'll take to get. It could either be 2 pluses or 2 minuses. Okay, either way I could get 36. Couldn't be a plus and a minus. It wouldn't give me a positive. And in this case, since I've got a plus in front here, they both got to be plus. Okay, well, so I can try 36 and 1. Now this gets interesting. Because it could be this way too. Okay. Now I can immediately discard this because I know when I multiply these out, I'm going to get a 36x from this and a 9x from this. Okay. And that's going to give me 45x. That's no good. I could even get 3x times 36 is 108x plus 1x, 109x. I could have 3x squared plus 109x plus 36 and it would factor. It wouldn't be that hard to find it. No harder than anything else. Okay, so you got to be kind of aware of that. Okay, well, anyhow, then we'll do this one. That's always a good one to check because there's only one possibility. It's going to be a 6 in both of them, right? So I don't have to do like the 36 here and the 1 here, and then the 1 here and the 36 here. Okay, well, this one, if you multiply it out, gives you 3x squared plus, that actually works. Okay. Why should that be? 6 times 3x is 18x. That's 18. That's 6x. That adds up to 24x. I thought I had that set up differently. So I made a mistake, but it came out. Okay. So anyhow. This is a process you need to follow on a bunch of examples until you get a feel for it. Because this tells you why everything else works. Now, there's a rule that says that in this case, that the two numbers have to multiply out to this and add up to this. Okay, it gets a little more complicated down here if we don't factor this first, and a lot of times you're going to get something that won't factor. Okay, so just had a question, so let's get that. A good question. If you need to go ahead and check this out using the distributive law, okay? So I'll go through the details of that again, because it's so important and so fundamental. And you're going to be kind of distributed law all over the place, so I want to understand it in every possible way. Okay, 3x plus 6 times x plus 6 I can write as 3x times x plus 6 plus 6 times x plus 6. Okay, then I can multiply that out. Okay. So 3x times x plus 6 is 3x times x here, plus 3x times 6 here. And similarly over here, 6 times x plus 6 is 6 times x plus 6 times 6. Well, this gives us 3x squared plus 18x plus 6x plus 36. And the 18x and the 6x add up to 24x. So I'll write that out. Right, it gets a little slow down at the bottom of the board, but there we have it. This thing zoomed back on me again. Wish there was a way. But I don't think there is. Okay, we'll stick with that. And I think it's still in focus. Okay. So that's the process. And you want to follow that process every time you do one of these. So if you're having trouble with this, kind of review the examples I did in class last week, week before last, before spring break. Okay. And look at the examples before I work them out, work it out yourself. Okay. Or look at examples in the book, look at examples online, wherever you find a source, but you need to work them out. You don't just read them and expect to understand it, right? Got to get your hands on it. Okay. So again, the process. See how many ways you can break it down. Check all those ways. After a while, you get the pattern and you can automatically reject a lot of the possibilities, okay? And you can use that rule, at least if you have a monic polynomial, the numbers have to multiply out to this and add up to this. It gets a little more complicated if you have a number in front of x squared. And even more so if you have a minus squared. Just many more possibilities. So you have to have a good feel for the distributive law. And then whatever you get, use the distributive law and check until you are sure you don't need to do that anymore. Okay. Okay, then we had another one, and this leads us into the special products that we want to talk about today. I'm going to do A and B. What's A plus B times A plus B? Okay, now I gave it to you as M plus N because I didn't want you to confuse it with the backward apostrophe A and the backward apostrophe B and just multiply out numbers, okay? Because it's pretty easy to do that. But generally it's done in terms of the symbols A and B. So by the distributive law, that's A times A plus B. Plus B times A plus B. Which again, writing it out in detail, this gives us A times A plus A times B. And then this over here gives us B times A plus B times B. Okay. That's A squared plus AB plus BA plus B squared. And then AB and BA are the same thing. Let's just write it out in detail. In other words, I can change the order of this multiplication because multiplication is commutative. And there we have it. Okay. Now this is what we call a special product. And really what I've got here is A plus B squared, right? So we understand that this is A plus B squared. So I can do this. And squares are kind of important, okay? Especially when you start talking about quadratic functions and stuff. And we'll talk about a little bit of that toward the end of the course, probably in the last week. Okay, we have A plus B quantity squared equals A squared plus 2AB plus B squared. So let's do 2x plus 3y quantity squared. Okay? I'm going to give you a minute and see if you can do this. I'll give you a hint right now. This is in the form a plus b squared. If a equals 2x, and b equals 3y. What we do is we're going to use a special product to do 2x, not 3x. 2x plus 3y quantity squared. Okay, most people are reverting to distributive law, which is really great because I've really emphasized the distributive law and I continue to emphasize it. But here's a case where we can bypass it if we know this formula. And if we don't know this formula, we can get it using the distributive law. It's real easy to figure out what a plus b squared is if you use the distributive law. Okay? But once we know this, if a is 2x and b is 3y, then we could just write this out as replace a with 2x. Well, we got a 2x here, right? I'm going to replace all my a's with 2x. So a squared will become 2x squared, right? Now, 2ab becomes 2 times 2x times whatever b is, right? I didn't leave it so good. Okay. Well, what else do I have? I got b, right? B is 3y. So I replace b with 3y, right? And here I replace b with 3y. And here I replace b with 3y. Okay? So all I've done is I've identified this is a square of a binomial. I know what a is, I know what b is, and I've got a formula for the square. So just plug these numbers in, or plug these expressions in. So this gives me, and of course this should be squared here. So this tells me that 2x plus 3y squared is what? Well, the square of 2x, and just be real explicit about the exponents. That's 2 squared times x squared, because of the way exponents work, just reminding us of those rules, which we were pretty good at. It's been a little while since we applied them. And that's often a source of confusion. People don't put parentheses around the expression. And then they treat this as just a 2 times x squared. Okay? So you got to be careful about that. Again, this is where you check. Okay? Where you want to check yourself when you do a few of these. So you're really clear about the rules, really clear if you got it right or not. Okay, so then that's 2 times 2x times 3y. Well, you can multiply the numbers. 2 times 2 is 4 times 3 is 12. And it's xy. And then you square the 3y. Well, that's 3 squared times y squared. And that's 4x squared plus 12xy plus 9y squared. Okay. So again, we just plug the two expressions in for A and B, and we get the result. We check. I'm not going to write it all out. You do it all. You see that 2x times 2x is going to give you your 4x squared, right? And you see that 3y times 3y is going to give you a 9y squared. And then 2x times 3y gives you 6xy, right? And 3y times 2x gives you 6xy. So 6xy and 6xy gives you 12xy. It works. It has to work if you did your steps right up here. But when you first start out, you probably want to go ahead and then multiply it out using the distributive law to see that it really works. Convince yourself that it works. Okay? That takes a little time, but the goal is to prepare yourself for calculus class, and it's going to be worth the time. Okay? Okay, well, let me give you another example, a simple one. Okay, let's see how much more I've got here. Okay, I can get this much. We're good so far. There's a piece of trash on the screen again. Okay, let's just take 5x plus 7 squared. Now, what's A equal? What's B equal? So now A plus B squared equals A squared plus 2AB plus B squared. And if you then plug your A and your B in, as I did here, let me go ahead and put this back up. Reference. That's not it. That could vary so quickly. Okay. So you see what I did before, what you just imitated with these symbols or numbers. Okay. Recording here. And what's that one chalk on? Okay. So what's A and what's B? A is 5x and B is 7. So square this, you replace A with 5x. Replace B with 7. A is 5x, B is 7. So the product is A squared, which is 5x squared, 2AB, A is 5x, B is 7, so that's 5x times 7, and then B squared is 7 squared, that's 25x squared plus 70x plus 49. Okay. So that's how you do this. Now, one big use of this is, what if I wanted to factor this? Okay, well, if this happens to be a perfect square, then it's really easy to see with the factor. And if I notice that 25 is a perfect square and 49 is a perfect square, then I can say, well, okay, maybe this is 25x plus 7 squared. Okay, maybe. Okay, so let's try one. Now this is a perfect square. Let's say we've got x squared plus got my numbers in my head and I'm writing down in the wrong place. Brain cells, come on. 16x plus 64. Now, there are a lot of ways you can factor that. You try x plus 1 times x plus 64 and x plus 2 times x plus 32. Bunch of different possibilities. X plus 4, x plus 16, x plus 8, x plus 8. Okay? But if I recognize that that's a perfect square and that's a perfect square, does that equal x plus 8 squared? Well, your formula, and I skip the step where I identify A and identify B and do all the plugging in, but your formula tells you it's going to be this, which is x squared plus 16x plus 64. Yeah, that works. Okay, using the formula. Now, it's pretty easy to factor this, once you use the factoring trinomials. But if you identify cases where you have a perfect square here and a perfect square here, then you're going to be able to check to see if you really do have a perfect square by checking with this term on it. Okay? So that's one of the main uses of that formula. That halfway makes sense? Okay. Now, again, open math should reinforce all that. They're going to say it a little differently than the way I say it, so understand it as you will. To try to understand really what's going on. And again, check, check, check. Okay? Take the time to check because you'll learn faster. Moving on to another idea. There's an equation. Okay. So can we solve that equation? Well, we're going to discuss that a little bit. So I'm going to. Okay, in discussion, somebody said, ask what value or values of x make this true. Ask if we can find a value of x that makes the equation true. The first suggestion I heard, I don't remember who, I couldn't tell who said it, but said, how about x equals 0? Okay, so that's a good thing to try. Well, plug in x equals 0 and see what you get. Okay, well, x equals 0 turns out not to work, but we got to try it. Because it seems kind of sensible, maybe. Right about 0 plus 5 times 0 minus 7 equals 0. Well, 0 plus 5 is 5. 0 minus 7 is negative 7. We get negative 35 equals 0. And that doesn't work. Okay, but it's a good thing to try. Also, this is leading up to the idea of polynomials. And, if this is an important function, you do want to find out what it equals if x equals 0. Okay? Very important to understand what you get if you plug in x equals 0. And it's an easy step. For almost any function, it's an easy step to plug in x equals 0. That tells you things about it to graph, and we'll talk about that later. Okay? But just like for linear function, if it's a y equals mx plus b, y equals 4x minus 9. Okay? Plug in x equals 0, 4x is going to be 0, so 4x minus 9 is going to be minus 9. That tells you the point of your y-axis. That tells you your y-intercept. And the y-intercept of a graph is almost always a very important quantity. Okay, and I think most of you are way ahead of me, but let's make sure. Okay, so the suggestion was x equals -5. Well, let's check it out. Does this equal 0? Well, -5 plus 5 is 0, right? -5 minus 7 is -12. 0 times -12, is that 0? Well, yeah. If you multiply by 0, you got 0. Always. Okay. And I don't know why I'm on this mask. I'm up here talking. Okay. When I come back to you guys, just in case I'm spreading something. Okay. So. Yeah, so how about x equals 7? And, well, plus 5 times 7 minus 7 equals 0. Or x is 7, so it'll be 7 plus 5. So that's 12 times 0 equals 0. 0 equals 0. Yes. Now I'm going to just foreshadow a little something since I mentioned about graphs. Okay. If I'm trying to do a graph of y equals x plus 5 times x minus 7, now this is something you're going to want to know in a few weeks. I'm just mentioning it now to get the whatever brain cells we've all got left kind of wrapping around the idea. So okay, well, here's the x and the y. We've got all kinds of information here about the graph. When y equals 0, x is -35, right? Well, when y equals 0, x is -35, that gives us a point here. I don't even know if I said that right, but I sure wrote it. And y is -35 when x is 0, so we have the point 0, -35. Y equals 0 when x equals -5. Okay, so let's put -5 any place I want to. But once I put -5 someplace, that tells me where I've got to put 7. Okay. It scales the graph. And just like I can put 0, -35 any place I want to in the y-axis. But that tells me what the rest of the scale is. And so I've got -5, 0. And that expresses the fact that y is 0 if x is -5. And then I've got the point, now see 7 is a little further from 0 than 5, right? Should be even a little further. So this is the point 7, 0. And now I know that my graph goes through these 3 points. I don't know what else the graph does, but it turns out that this graph is a graph of a quadratic function, because if I multiply this out, I get x squared minus 2x minus 35, right? So now, and we haven't done this. We haven't talked about the graph of the quadratic function. It's kind of like this, okay? Now, I kind of screwed it up. Made it look like something that isn't. It actually keeps going a little bit lower here and then turns around. From this point here, you got an axis of symmetry, which is halfway between the zeros, and we'll worry about that later. But again, this information gives us important information about the graph, which is one reason we do it. So we understand these functions and polynomial functions, which will come along a little bit later in the course.